All right. Mic's on. Mic is on. Good morning, everyone. Sorry, I'm about a minute late. My dog didn't want to come inside. All right, so some friendly reminders are on the quote board for the moment, and I have one to add as well. Okay. So we covered 1.1 last time, which is why it's due in a week from last class, which is June 2nd. Remember, due times are always midnight unless otherwise specified, 11:59 p.m. technically. The 1.2 and 1.3 homework are due on June 4th, so we are planning on covering those. If we don't finish today, then I'll modify the 1.3 at the last part of class. I assigned the Excel heart rate. That'll be our first actual official Excel homework. As I said, the the chapter 01, which is due tonight, that's kind of an unofficial Excel homework. I mean, it's still Excel homework. It's something that we normally would have just done in the lab together and called it participation. But I still want to make sure that you completed that. So if you're wondering what the chapter 0 spreadsheet is, it's the thing that's in your guided worksheets. It's the same one that we built on the second day of class. So you have an entire video detailing exactly to the T how to set that up. If you're not watching these videos, you're not going to have a good time in this class, and make sure you're doing that. Our first quiz was due last time, that syllabus quiz. I know one or two of you, I had to do some simple edits, like you didn't pay attention to the instructions. There's two things I always say. One of them is pay attention. The other is, does it make sense? So the pay attention was, like maybe I said to write it as a number and you wrote it as a word, or maybe you put the .com in there or something like that. But again, please pay attention to the instructions. I was pretty lenient with that one, and I haven't done all my edits yet. So there are one or two of you that are going to get a point back out of the 5 points, but you'll know if you will or not. It's not going to be something like the answer was 2 and so the answer was 5 and you said 2. That's not going to get you points. It's if you said my email was rbeckner instead of rbeckner@tcc.edu or something like that. Your second quiz, this is going to be in Canvas by 1:30 today. I will try and have it. I always say this, and sometimes I can hit it, sometimes I can't. I'll try and have it by 11 a.m. today. I think I can do that because I already have the file created, so it shouldn't take me too long. And I can do that while this video is converting. And I don't have anything to prep for my next class because I already did it last night. So that's nice. So anyways, the second quiz that we'll have for our course, this is going to be due on Tuesday. Remember, quizzes are usually due the next class. Homeworks are due a week later. So this is going to be, I think, 4 questions, and it's based on the videos under video resources. And I tell you which video to go to. You're going to type up a sentence, or you can write up a sentence and then take a picture of it, but you will have to submit a file to me in Canvas. So it'll be a submittable homework assignment, just like that chapter 0 spreadsheet is. As a reminder, practice with Excel over and over. Do things wrong, then do them right. Do them wrong 50 times, then do it right for the 51st time and understand why it was right. If you don't understand why it was right, do it wrong again, then do it right again. And then assuming we finish 1.2 and 1.3, that means you should be reading 2.1 next. That first discussion board is due on the 28th, and this is something I need to talk about. Do not answer all discussion boards. Leave some for other students. I won't say who it was, but somebody I think went through and answered every single one, and that is not how discussion boards work. The discussion board is you answer 1 or maybe even 2 of the things at a time, and then the other people have an opportunity. So I know that someone answered them all, and I haven't said whether they were all right or wrong. Maybe they are, maybe they aren't. I would still like y'all to go back and participate in that discussion board like they aren't all already answered. So again, just kind of go in and start from the top. And I think they may not, I needed like 4 different car annual costs. And I think they only put one of them in there. So that's still an opportunity. But again, some of the other questions that were answered, if you think they're wrong, put your version of it. Have a discussion, because especially with that particular homework, there's a lot of room for interpretation with the, hey, is it a function or not? You know, just because one person said it is doesn't mean it is. Just because one person says it isn't doesn't mean it isn't. Unless it's your teacher that says it is, then you know that everything's okay. So I'm gonna likely have another discussion board set up for next class, and because of that weird issue, I'm gonna add another day to this. So I need to go back and edit that. I'm going to change that discussion board, the original one, to the 29th, just so that everyone's got a little bit more of an opportunity to go back and answer them. But the next discussion board will still be due on the 2nd. So whatever discussion board I assign today, that one will be due on the 2nd by midnight. Okay. So where did we leave off? So one of the last things we did was talking about these fixed cell references. Excuse me. I swear the air is drier in my house. I never cough this much at work. I mean, I still cough a little, but I cough way more in my den. Trying to decide something. Okay. So we talked about fixed cell references last time. That was one of the last things we did. And this is when you have an Excel spreadsheet and you're applying a formula, but you're applying it across a bunch of different rows and or columns. But in that process, you don't want some of the cell references to move, maybe just not move left or right, maybe not move left, up or down, or maybe not move at all. So we end up needing these cache symbols. And once again, this is something that you need to not be terrified of trying, and just try it and see how it works. See how it reacts to where you put these cache symbols, because that's going to make you actually learn. Just reading this one time, oh, a cache symbol in front of the letter, I know it instantly. Oh, a cache symbol in front of the number, I know it instantly. Absolutely not. When I first learned this, it took me a dozen tries to get it right consistently. And guess what? Every now and then, I'll still put a cache symbol in front of the letter when it was supposed to be in front of the number, or vice versa. But what happens is, after I apply that formula, I go, does that make sense? And I look at the answers in the boxes and I see if they are predictable. And if they're not, if you start seeing blank answers, then it makes it super obvious that it's wrong. Or if you see weird, wacky numbers that shouldn't be there, that says something's probably wrong. So again, don't be afraid to do things wrong before you do them right. That's how we learn. And I'm going to talk about likely, I think today based on the timing, a great exercise to practice this out, because your third Excel homework, the BMI, 1.8 BMI, you're going to have to use these. You're going to have to understand these. Okay. So actually into the new stuff. 1.2, order of operations, and let me bump this down so it's all in one spot. The order of operations, this is something that you are supposed to already know for this course. But I bet if I went on your Facebook pages and found you having an argument on some random meme, hey, you know, you're a genius if you can solve this problem and it's 3 plus parentheses 5 minus 9 times 7, close parentheses, blah, blah, blah. And then people like to have arguments. And whenever I saw those on social media, when I used to care about social media, I never cared about it when I used to use it, that is to say. You know, I always saw more wrong answers than right. And the thing about wrong people is they tend to be pretty passionate, and they can express themselves so much that they feel like they're right. And, you know, it's not the worst thing in the world to be wrong and think you're wrong and express your opinion, but when it's something definitive that has a right or wrong answer, it's not just an opinion. It's another story. So you've got to make sure that you have this idea, this concept correct. So PEMDAS, please excuse my dear Aunt Sally. You should have all heard that at least 10 million times in your life before now. It's a good mnemonic device to help us remember parentheses, exponents, multiplication, division, addition, subtraction. Here's the problem. Here is the problem. You see 6 words, so you think 6 steps. Look at that list. There are not 6 steps. There are only, what do you see? 1, parentheses, 2, exponents, 3, multiplication and division from left to right in the order seen. Multiplications and divisions are kind of like a yin and a yang, and so are addition and subtraction, in that they're really the same operation, but they're mirrors to each other. And that particular mirror is called a reciprocal. And there are properties that multiplication has that division does not have, but in terms of an order and when it's supposed to be done, in that regard, they are the same. So if you see a multiplication, then a division, then a multiplication, then a division, you were supposed to do them in that order, not all the multiplications, then all the divisions. Again, not that. So if I saw 2 times 3 divided by 6 times 9, if I saw 2 times 3 divided by 6 times 9, somebody on Facebook's going to come in and say 2 times 3 is 6, 6 times 9 is 54, and try and do 6 divided by 54, and it's a fraction. And just because the answer is a fraction doesn't make it wrong, but it is wrong. When in reality, what you're supposed to do is 2 times 3 is 6, then the 6 divided by 6 is 1, and then the 1 times 9 is 9. And that is correct. The same goes for additions and subtractions. They count as the same step. So if you see addition, subtraction, addition, subtraction, addition, subtraction, you do them in that order from left to right. It's only when you start mixing up additions with multiplications or subtractions with multiplications or divisions or anything like that, that it's not just left to right. You have to do the step 3, then step 4. So if I saw something like 2 plus 3 times 5, on Facebook, someone's going to go, oh, well, 2 plus 3 is 5, and then 5 times 5 is 25, and that is wrong, 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 because they didn't follow Pemdas. Multiplication goes first. 3 times 5 is 15, so that's 2 plus 15, which is 17, and that is correct. Now, here's where there can be complications. You're allowed calculators in this class because this is what I like to call a math class for the real world. And in the real world, you got your cell phones on you probably 23 hours of the day if you're like most people. At least most people my age or younger. But not all calculators are built the exact same. There are calculators that exist that do not follow the order of operations because it just says, all right, I'm going to do whatever this person types next. There are many, 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 many calculators that do follow the order of operations, and it waits until you've gotten to the end of the string to start crunching things out. But I can't promise what type of calculator you have sitting in front of you, whether it's a TI-30X-2S, which is the recommended calculator for this class at about 15 bucks, or your Apple 7, iPhone 6, 7, whatever, or a Droid. I don't even know cell phones very well, quite honestly. I was on a flip phone until a couple of years ago, but not the point of the conversation. The point being, technology can be different. Texas Instruments TI-83, a graphing calculator, one of my favorite instruments. If I want to do exponents where there's a whole bunch of stuff in the exponent, I have to wrap it in parentheses, but a student who's got a TI-80, I want to say 9, just a slightly newer calculator with more features, that has an option where the exponent is automatically set up correctly and doesn't need the extra parentheses. So in the same company, you've got calculators that operate differently. So you've got to make sure that you can do this stuff without a calculator with basic arithmetic. That way you can check your calculator and understand how it operates going forward. What do I want to say? Exponents with negatives, this little thing right here, this is something that you'll never actually have to do by hand. You are not going to be told what a negative exponent really means in this class, besides the fact that it's reciprocal. That's all I'm going to say. But at some point in this course, we'll come across problems that are like this. Maybe 3 plus 5 to the negative third. Well, guess what? You can just type that in your calculator. Give me a second. Come on. Let me minimize. I would love to have a computer that's actually mine for this. Here we go. So here's my TI 83. Again, you really only need a TI 30 in here, but this is fine. So 3 plus 5. Then this is my exponent key. It looks like a upside down V. So if I hit that and then a -3, the answer is that number right there. And in my math lab, or you would just say, it would say, hey, round it to 2 or 3 decimal places, whatever it might say. So we will have to use negative exponents every now and then. But this is another case of, depending on your calculator, if you typed everything in that order, you might not get that answer. Some calculators, you have to hit the negative after the 3. So when I typed this -3 right here, there are calculators where you have to type the 3, then the negative. My calculator, I type the negative, then the 3. And again, I can't sit in front of you physically and say which to do. So you're going to have to figure this out. So there is an example. If you type the negative first and don't get that answer, then maybe you should type it second and see if you get the answer, and then say, make a note to yourself and say, hey, I need to do the negative last. And it's not just with exponents, that's in general the way that you're doing that negative. All right, then we have this little detail about math form versus Excel form. So when we're used to doing normal arithmetic problems, they wouldn't look like this. This problem would look like 3 minus 4 on top of 7, and then a +1. So the Excel form is what I have typed. The quote math form is what I have written to the right. So why did I put the 3 minus 4 in the top of the fraction, but not the 7 plus the 1? What's the major difference there? What's the element that said, hey, I need the 3 minus 4 in top, but on the bottom, I'm only putting the 7, not the 1? It's the parentheses. Because there's a parentheses surrounding this 3 minus 4, that tells me, hey, that entire thing needs to be divided by the 7. So when I set it up as an old school fraction, the 3 minus 4 is all on top, so that divides by the 7. But the 7 plus 1 does not have a parentheses around it. Let me just show you what it would have looked like to have everything in the bottom then. I would have needed this. If I have parentheses 3 minus 4, then slash parentheses 7 plus 1, that right there would be 3 minus 4 in the top over 7 plus 1 in the bottom. Or what if I had just had this, 3 minus 4 slash 7 plus 1? This right here, there's no parentheses, which means this fraction only uses the 4 and the 7. So it goes 3, then a minus. That's not a 7 first, excuse me. A 4 on top, a 7 on the bottom, and then a +1 to the side. 3 minus 4 sevens plus 1, and that would be the most annoying one to simplify because it's an ugly fraction. Not that the first one's super simple either. And then you'd go through and do your order of operations. Okay. This solving simple equations, we're not going to get to that yet. Let's go back to this. So guided worksheets. So this was previously assigned. This was previously assigned. This was previously assigned. There's your heart rate preview, your TV loan preview, which will be assigned very, very soon. And we're going to get about 1 Excel a week. Here we go. 1.2, and by the way, there's the title of the section, Analytic Representatives Equations. In other words, just doing basic math. Okay. So order of operations we already talked about. Here's some examples of the order of operations being applied. You got a multiplication and subtraction. You do the multiplication first. 3 times 5 is 15. Minus 2 is 13. Here, you've got the 5 minus 2 in a parentheses, so that tells us to do the parentheses first. Parentheses are used to circumvent the order of operations. So because of the parentheses around the 5 minus 2, that says, hey, do this first. 5 minus 2 is 3. Then the 3 times 3 is 9. So I can't, never mind. I don't want to have to do that for just 2 quick problems. And at the bottom, something completely different, 5 plus 2 times 3. If you think it's 5 plus 2, which is 7, then 7 times 3 is 21. They say that's wrong because you did the addition before the multiplication because you weren't paying attention, you were rushing, you weren't taking your time, or you just don't know the order of operations, in which case, learn the order of operations. So the 2 times 3 is 6, then the 5 plus 6 is 11. So, guided practice activity number 1, and this is where our first discussion board is going to be. So we'll do a couple of these, and I'll leave the rest for y'all because I don't want to take too many. So for each of the following, compute using proper order of operations without a calculator. So let's do A for now. So we'll do A. It says 2 minus 8 divided by 4 plus 6 times 2. So this star is a times, a slash is a divided by, this upside down V is an exponent. Parentheses say, hey, do this first. We could also have absolute values, all sorts of good stuff. All right, so 2 minus 8 is negative 6. Then it's negative 6 divided by 4. Nope, already did something wrong. Order of operations, we have divisions and multiplications. They should come before additions and subtractions. So let's leave the 2 and the minus. The 8 divided by 4. Now don't do the multiplication first. Do the division first because that's from left to right. 8 divided by 4 is 2. Plus. And some of you are going to do these steps at the same time. The 6 times 2 is 12 because it's separated by the plus. I'm just going to be very careful and do one single step at a time. So that's a times there. So then it's 2 minus 2 plus 12. The 2 minus the 2 comes first because additions and subtractions are done at the same time from left to right. So 2 minus 2 is 0. And then 0 plus 12 is 12. So that would be your answer. I will also do C. C is a little bit more. So I'll leave you B, D, and E. So discussion board. DB means discussion board for B, D, and E. So 60 divided by parentheses 2 plus 8 minus 2 exponent 3 times 2. Pemdas, P, parentheses. So the 2 plus the 8 comes first. So that's 60 divided by, and you can switch to the old school division symbol if you prefer at this point, 10. I don't need the parentheses anymore because I've done everything inside of it, unless it was a negative. Then minus 2 to the third times 2. I'm just keeping the notation the same. Pemdas, no more parentheses, so exponents. That's a 2 cubed. 2 cubed is 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. So that's 60 divided by 10 minus 8 times 2. We have a division and a multiplication. We'll do the division first because left to right. 60 divided by 10 is 6. Then the minus 8 times 2. 8 times 2 is 16, so that's 6 minus 16. I can call that negative 8 times 2, and that's negative 16, and you still get the same thing. And 6 minus 16 is negative 10. No excuses for not being able to handle signed arithmetic. I should be able to give you a signed arithmetic quiz without a calculator at this level, and everyone get 100 on it in theory. I know that would never happen, but that's what's supposed to be mastered. Fractions, decimals, signed arithmetic. You're supposed to understand that stuff. So again, I'm going to leave B, D, and E for you to do. One student each. Please show your work in the discussion board. Please try and type out something like that. to the best that you can. So I left some easier ones for you. For number 2, write down how you would type these into Excel as a formula. So if you wanted Excel to do this stuff for you, oh, okay, I've got 5 plus blah, 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 or 9 plus 2, blah, 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 blah. And let's say you wanted Excel to do it for you so that you don't have to think and turn on your brain. So you could type these up as an equals. Remember, in Excel's a formula always starts with an equals and then your other stuff. Otherwise, it's just going to display what you wrote instead of processing it. So this is kind of flipping the script on example 1. I don't even want to know what the answer is. I just want to know what the setup would look like. And the setup should look very similar to the start of the example 1 problems. So you'll need to write some parentheses and maybe some carets for exponents. I actually am going to leave A and C for you, but we'll do B because I think this is the most complicated one. C and B are very similar, so I feel like I need to do one of these for you to really see the other. Okay. 5 plus, and then a big old fraction. So with fractions, you typically need parentheses to separate the top and the bottom. In fact, the bottom's already got a parentheses for the exponent, so that might be helpful. So this is going to go equals. Then 5 plus. There's nothing super special going on here, so just a 5 and then a plus. But then we've got our fraction. Now the 2 is the only thing in the top. Because 2 is the only thing in the top and it doesn't have an exponent being applied to it as well, I don't need a parentheses. I can go ahead and do slash. Do not use this symbol. Do not use the regular division symbol. Excel doesn't have that. Excel has a slash for division. Now I will spoil this because C in the top has multiple terms in the top. You do need a parentheses, and in fact, you need a parentheses around the whole thing as well. So there's going to be nested parentheses in C. There's going to be this kind of thing going on. 2 parentheses at one point. You'll have the open the parentheses, then you'll also need one for the 9 plus 2. I just want to go ahead and mention that. All right, so back to B. So 2 divided by, now there's multiple things in the bottom, so even without the one seen, if I didn't see the exponent in this extra parentheses, I would still need to have this as an 8 times 4. I would still need that. Hold on. But that stuff is there. So 2 divided by parentheses 8 times 4. Close the parentheses, then an exponent. Now the exponent is this 3 plus 1. This complicates things. So we go caret. If I do this, it's wrong. 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 Because this exponent is only going to apply the 3. This plus 1 would not be part of the exponent. So it's going to think, oh, I just want to do the 8 times 4 and then cube it. Then add 1 to whatever that is. So what we need is a parentheses. We're going to have to wrap the exponent in parentheses. You will need the same thing for C. That 4 times 6, you're going to need a parentheses. Spoiler alerts. So very often you need additional parentheses when you try and put things into an Excel format. This is important to understand. So when you have an Excel homework, like BMI, that has a slightly complicated formula that you'll be typing in, and they'll have it written out something like what B looks like, but then in Excel, you have to write it out like what I have in the red. So you got to know whether it's right or wrong. So maybe try out one of the numbers, plug it into the regular math way, see if you get the same thing in the Excel way. And if you do, that's a good sign that it's correct. All right, so again, discussion board, problem 1 and 2. From 1, we're going to do B, D, and E. From 2, we're going to do A and C. 1 per student, 1 per student, 1 per student. If you see someone did something that you think is incorrect and you feel confident in that, come back and say, well, this is what I did, and then have a discussion. You are more than welcome to come back. If you were the original poster and someone comments on your post, please feel free to have an open conversation about that. As I said, I will occasionally come in and correct people or just give out answers. I won't do it every single time. I will come in and give answers to this one eventually, but not immediately. Like I said, I'm trying to treat these post-class discussion boards like our group activity, but just kind of a smaller amount of them. Normally, you would have done all of these in class. And I will start rambling less about the dynamics of this course as we continue, but I just feel like because there's so much stuff that I have to, especially since there was a syllabus quiz and not everyone got a 100, which is, you know, not optimal, but it is what it is. All right, so let's clear our screen. Let's take off annotate and let's scroll. Do I want to do this part yet? I'm thinking. Let's hold off on that. Solving simple equations. So if you have something like x plus 5 equals 9 or 3x minus 7 equals 12, we're not going to be solving crazy equations by hand in here in general. We'll have some simple equations that we solve by hand that you'll see in your My Math Lab homework, that you'll see a couple on a test. But we mostly do a lot of proportions, which is still, you know, in this ballpark, but it's just the same thing over and over and over and over and over. But the basics of solving an equation, which are our balancing scale, the old school balancing scale that you probably only see in a science class at this point in your life. As long as the scale is given to you balanced, like x plus 9 equals 17, and it's solvable, then whatever you do to one side of the scale, just do to the other. You can do anything. The only exception is you can't divide by 0. But you can pretty much do anything to an equation you want as long as you do it to both sides. Whatever you do to one side, you do to the other side when you're trying to move things around. But you don't want to just add 19 to an equation randomly or subtract pi or multiply by your mom's birthday or something weird like that. You want to have a goal in mind, goal-oriented, you know? So you want to get the variable by itself. So we tend to work in opposites of what's with the variable. So if you see x plus 7, the opposite of adding 7 is subtracting 7. So that's what you do to both sides. Or if you see 5 times x, you would need to divide both sides by 5. Or if you saw negative 5 times x, you'd want to divide both sides by negative 5. So you'll see a couple simple equations to solve in your homework. Just a really quick example to the side. Why is that highlighted? There we go. Maybe you have something like 3x plus 5 is equal to 30. Nothing crazy. The x is what we're trying to solve for. That's what we want to isolate, get by itself. The 3 and the 5, they've got the they've got that virus going around that nobody wants, and the x is trying to be safe, so it wants the 3 and the 5 gone. It wants it out of its room, so to say. So it's got to move the 5 and the 3. The 3 is being multiplied, the 5 is being added, so we'll have to divide the 3 and subtract the 5, but not necessarily in that order. Solving equations does not follow Pemdas. Trying to move things from side to side, it's more about what's easier. And if you try to divide both sides by 3, the 5 is not going to clean up easily. So I would hold off on that. I would actually subtract the 5 first. And if you are rusty with this stuff, then I suggest that you go to the internet and find a whole bunch of these, whether it's on Purple Math or on Khan Academy, or just do the few in the homework over and over and over and over and over. But I don't really think there's enough in the homework to justify calling it mastery. And then you divide both sides by 3 because that's 3 times x. 25 does not divide by 3 evenly, so you just get x equals 25 over 3. It doesn't reduce. Sure, you could call that a decimal, which would be what, 8.3 bar. If you're told to round, you could call it 8.3 or 8.33 or whatever. But if you're not told to round, if you're not told to write as a decimal, 25 over 3 is really what the answer should be. And if you put that in a calculator, it's going to give you 8.333333. And if you type that into a problem that doesn't want a decimal, if it doesn't want to round a decimal, it's going to mark it wrong. So your calculator can't do everything for you. calculator cannot do everything for you. Trust me on that. Where is, there it is, okay. So we'll do that next. This right here, make a multiplication table before trying 1.8 BMI. So again, your third Excel homework is going to be on BMI, and that should actually be part of 1.3. I have that in the wrong spot. 1.3 starts here, which that title is Numerical and Graphical Representations. Charts tables. So 1.2 is a really short section, short and sweet. We probably would have spent another, like I said, 15 minutes in class doing the group work, but that'll just be in the discussion board after class. And because of that, if I ever feel like I can cut class a few minutes early, I will, since technically a chunk of class you can argue is being done outside. But you know, just take that with a grain of salt. It's probably not going to happen too often. Believe me, I am trimming other things out of this course because of that, because I'm having to assign just a little bit extra outside. I'm doing less Excel homeworks. Normally I'd do 11 or 12, and we're only going to do like 8 or 9. I would normally do 2 projects. We're only going to do 1. Oh, this is a bad one. Excuse me. Make a multiplication table before trying 1.8 BMI. So that will be the first homework that uses this stuff. So I'm actually going to copy paste this just for a second because it's still relevant. Sorry about that. I can't get to my on-off switch quick enough. How to fix cell references, the cash symbols in front of a letter, a number, or both. So let us together, quote together. So if you're able to actually work on Excel while watching this, that would be awesome. If not, what you should do is after class, go and replicate this. In fact, I would normally not have my students in a lab for this one because I would have run out of lab time. We only get so much. So I'd say, hey, before you go and try 1.8 BMI, do this as a homework. So you'll be able to see exactly what I'm doing. I need to open up Excel. So this is an extra, I'm not going to say homework assignment because I'm not going to make you turn it in, but this is something you should do. This is something every student should do to help gain a better understanding of these fixed cell references. You don't learn by watching, you learn by doing. I'm not going to say you. Most people don't learn by watching, they learn by doing. I know that just being told, hey, put a cash symbol in front of this, put a cash symbol in front of that, I kind of pick up on it, but I didn't master it until I actually tried it over and over and over and over and over. So multiplication. So it doesn't matter how big you make your table. You can go to 20 on each of these. You can go to 5 on each of these. I'm going to go to 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Not 190, 10. There we go. Did I actually have to type those? No. I could have just typed. Why does that work sometimes? There we go. I could have typed the 1. I could have made that cell active, grabbed the fill handle, dragged it down, and brought it down to space 11. But look at where my small black plus sign is, and it just says 1. That's saying that all of these are going to be 1s if I let go. And sure enough, they are. I need to move this for a second. So if I grab it and hold and then hit Control and let go, then it will do 1 through 10. Or I could have just had 1 and 2 labeled, highlighted both of those, then grabbed the fill handle and took it down. There's multiple ways to get the job done. Then we need to make the columns of 1, 2, and you can do the same thing, but it's quick to label. So I'll just do it by hand. So we're going to do a 10 by 10 multiplication table. Do you have to do this with multiplication? No, you could do it with addition. So maybe after you do the multiplication table, if you still don't feel confident with your cash symbols, do another one with additions. Now we're using cell references for this. So check this out. You might say, oh, okay, well, this is just supposed to be equals, and it's multiplying the numbers in the first column by the numbers along the top row. And in fact, that's not what we want, so we undo. I have that silly option above. I want to bold these to make sure we can tell the difference. So I'm just highlighting them and hitting Control B, or you could have highlighted them and clicked this bold icon. So equals. Now we're taking the numbers along this first column and multiplying it by the numbers along the first row. You can type the cells or just click them. And I would like to remind you to use the proper version of Excel. If you are using the online version, if you're just going to that the VCCS website, Office VCCS, whatever it is, where you're supposed to download Excel, if you're just going there and opening it, there are things that is missing. There are options that it is missing, and it will mess up your homework. If you are on a Chromebook, you're always going to have those issues. I don't even think it lets you download Excel because it's proprietary software, whatever nonsense issue. So you may need to borrow a computer from someone, you know, a family member, a friend, whatever you have to do in these trying times. If there's a library open, I don't know, whatever you have to do, but still, of course, be safe. Do what you have to do. All right, so we're multiplying the 1 and the 1. So I can click that one, and then I can do my times, just Shift and 8 or just over your number pad to the right side, and then times this one. So I could have typed A2 times B1 or clicked A2 times and then clicked B1. And 1 times 1 is 1, so that looks pretty good. So now you might think, okay, well, I can just make the cell active where I typed my formula. If I double click it, it shows where the blue and the red boxes are, which are correct. If I hit enter. So now if I make it active, if I grab the fill handle and drag it down, all these numbers should be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, because we're just multiplying all the 1 through 10s by 1. It's the multiples of 1. That does not look like the multiples of 1, does it? So this is wrong. This is terribly wrong. And if I then grab the fill handle and take it all the way to the right, these numbers get so big that Excel can't even calculate. These numbers are unfathomably big. So this does not look like the multiplication tables of up to 10 and 10. So something's wrong. If you double click any of these, the blue and the red should show you what you're multiplying. So if I double click this one, that should be 6 times 4, the bold numbers. And in fact, let me color these for even more emphasis. So we should be multiplying the blues. So if I were to double click this, that should be 6 times 4. But that blue box is not over here under the 6, and that red box is not over here in the 4. In fact, because they're blue. Yeah, you can still see it. Okay, that's not a problem. So the blue boxes and the red boxes are moving when they shouldn't be moving. So that says we need to fix some cell references. So let's undo filling everything. Oh, undo, 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 undo. There we go. So back where we typed this original formula, we definitely need some cash symbols. Maybe we need to fix everything. Maybe that's your first instinct. Just fix everything. Just fix everything. Fix everything. And then if we grab the fill handle, drag it down, well, that doesn't look good. So I'm pretty sure if I start filling it right, nope. All of these are just 1 times 1 because look at this. The blue and the reds never move no matter what reference I grab. No matter what cell I grab, excuse me. Because you double fixed everything. So they never move. The blues never move down or right. The reds never move down or right. So that's not too good. Okay, so let's go back to when it wasn't double fixed, and let's just play with let's only worry about the blue stuff for now. Let's just focus on the blue and get that right, then we'll worry about the red. So maybe we need to put the cash symbol in front of the letter. So I don't remember what Mr. Beckner said. I don't remember which one fixes which. I'm just going to try randomly. Believe me, been there, done that. I wouldn't listen to me 100% of the time either. So I just put a cash symbol in front of the letter for the blue one. So what that means is the letter won't change. Now the letters are left and right. So this is actually going to prevent this from moving left and right, but not up and down. Let's see if that's good enough. If I grab the fill handle, well, dang it, those still don't look right. And if you double click any of these, you can see that the blue box is going down, but the red box is also still going down. Well, we want the blue box to go down, so that's fine. Maybe this cash symbol is okay, maybe it's not. Maybe it's the red one that's an issue though. So I don't know if that's right or not. So let's undo. And when I say this, I actually do know, just to be fair, to make sure you don't think I'm crazy or something. Why is this guy teaching? He doesn't know anything. I'm doing this kind of what if analysis. What if I do this? What if I do this? Trying to just figure it out on my own. So instead of putting the cash symbol in front of the letter for that one, and we're just trying to get this right, maybe we put the cash symbol in front of the number here. So now let's see if that fixes this. Well, that looks bad still. Undo, our favorite button. Look at this. The blue box is not moving down when it should be, so we definitely don't want the cash in front of that number, so we write down, don't put the cash in front of the number for the blue one. That was definitely wrong. It was better to have it in front of the letter than the number, at least. Now, I'm not saying that in front of the letter is right or wrong yet. I'm just saying it definitely shouldn't be in front of the number. But the red box is still moving down when we don't want the red box moving down. The red box is moving down when it shouldn't be moving down. Okay, well, when we put the cash symbol in front of the number of the blue one, it stopped moving down, so maybe we should just do that for the red one instead. So let's undo. So let's put the cash symbol in front of the number of the red one. Now let's see if this helps anything. So there's no cash symbols in the blue, just in the red number. Highlight active, drag it down, fill it down. Holy cow, we got some good numbers. If you double click, the blue box moved down, which it should. The red box did not, which it should. Enter, double click down here. The blue box moved down like it should. The red one did not. So everything's looking good for now. So this first column's good. So now what we can do is highlight the column, grab the fill handle, drag it right, and let's see if that bottom right number is 100. Okay, so we're getting there, but something's still amiss. So let's see if we can figure out what's wrong now. So if I double click this one, the red box is okay, but the blue box has moved right. We didn't want the blue box moving right. It should be over here on the bold for. Oh, and I removed my colors at some point. I hit undo too many times. I'll fix that in a second. So again, now the blue box is moving right, which it shouldn't be, and the red box is good. Let's see about over here. Red box is good. Over here, red box is good. So I've got the reds perfect. We only need that cash symbol in front of the number because we don't want the red box moving down. We do want it moving left or right. So we don't want to fix the letter. If you put a cash symbol in front of the D, then those red boxes would not be allowed to move left or right. It would be stuck in the D column. So again, the cash tells you a column or row to stay in. So by telling this thing, hey, stay in row 1, it never leaves row 1. It never goes down to row 2. But it is allowed to move from letter to letter because we didn't fix the letter. All right, so the red's good, but the blue's bad. The blue is moving right when it shouldn't. The blue is allowed to move up and down. We want it moving up and down across these numbers, but we don't want it moving right into the actual data. So undo, 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 undo. back to when there was just one single spot with one single formula. So we said the red is right. So we're not going to do anything to the red. The blue, maybe you think you need to put a cash symbol in front of the number. Now we tried that earlier. Let's see what we get. Does that look good? No. Does that look good? No. Everything looks worse now. Now the red box is still in the appropriate spot here. The red box is still in the appropriate spot here. The red box is still in the appropriate spot here. But the blue box, this blue box should be over here, and it's now over here because we're not allowing this thing to move up and down. So it's staying in this row, but we're allowing it to move left and right, which is not what we want. We don't want it moving left and right. So, okay, undo, 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 undo. Let's get this right. Let's get this right. And let's recolor everything. Paint, paint. All right, so in our formula, we said the red was fine, the blue is bad. Let's now put the dollar symbol in front of the letter. So that says, for the blue stuff, for this blue box, because there's a cash in front of the letter, we can't change letters. It's stuck in the A column, but we are allowed to move up and down. Now that's good. We don't want to be moving away from this blue section. So we don't want it moving left and right. We only want it moving up and down. For the red one, the cash symbol's in front of the number, which says we can change letters but not numbers. So the number says we're stuck in this blue, but we can change from letters B through K. Hit enter. Highlight the cell or make the cell active where you put the formula, fill it down, let go. Hey, that looks good again. Grab the fill handle again, grab it right, let go. And there is our accurate multiplication table. If you don't believe it, go through and check on your own. If you double click any of these, you can see that the cell references are in the correct spots. It's around the 9. It's around the 7. Sorry, excuse me, 8. 9 times 8 is 72. If I hit enter, you can see your 72. And you can see the cell references. It's using A10 and I1. Here's your A10, here's your I1. The cash symbol's in front of the A, which says, hey, you never get to change the A's for the blue reference. The cash symbol's in front of the 1 for the red, so you never get to change from row 1 in the reds. So again, this right here was the formula that got everything done properly based on where I have things placed. Now, if I had started the multiplication table down here, the 1s and the A's and the B's would be drastically different. If I did, let's do the addition table. What is going on? I'm not on the home, that's why. Home row. So if I want to do addition, 1 times 2, 3, 4, 5, 6, I said times add. Then 1, 2, 3, 4, 5, 6. What's happening? So again, our formula should be using only things from these blue sections. So we go equals. And we just need to add this cell plus this cell. See, now it's A18 and B17, whereas before it was A2 and B1. And that has no fixed references, so when you start filling it all around, these are going to look terrible. 1 plus 10 is not 56. And you can see that the blue's in a good spot, but the red's in a bad spot. If you were to fill these right, I'm just going to do a couple of them. You can see the blue's moving right when it shouldn't. We don't want the blue moving right to a different letter, so that says, hey, fix the letter. We want the blue box here instead of where it is, and that's a different letter, so that says we should have fixed the letter. The red box is moving down when it shouldn't be, so it should be up here. This is where the red box should be in that row 17, so we need the row fixed. We don't want it moving up or down, so we fix the row for the red. We don't want the blue moving left or right, so we fix the letter. Undo, 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 undo. So again, for the blue, we don't want this moving left or right, so we fix the letter. For the red, we don't want the red moving up or down. We only want it moving left or right. Remember, the cache tells you what you can't move. So we don't want this moving up and down, so we can't go to different rows, so we cache the row, we fix the row. Hit enter. 1 plus 1 is 2. Let's grab this, and you can fill it right first if you want. You don't have to go down first. Those look good. 1 plus 10 is definitely 11. Fill the rest out. 10 plus 10 is definitely 20. And if you double click, you can see the blue and the reds on any random box are in correct spots. Do this on your own. After you do it again. After you do it again, do it again. Do it until you can knock this out in a couple of minutes. This is an assignment that you should be able to complete in no more than 5 minutes. Making a multiplication table or making an addition table, one or the other, 5 minutes. Now, the first time you do it, you're not going to get it done in 5 minutes. Now, if you literally just follow me to the T while watching the video, you'll be able to get it done in 5 minutes. What I mean is, do it without watching me. So do it one time watching me, get it correct, then try and do it without watching me. And then a couple days later, try and do it again to make sure you've retained that information. This is something you need to do over and over and over, because about 3 of our homeworks are going to have tables of information like this. That heart rate homework is only going across a single column or a single row for things. The BMI assignment, you're going to be going across rows and columns, so you will absolutely need fixed cell references. If you don't use fixed cell references in that 1.8 BMI homework, you will never get it correct. So why am I suggesting to do this before BMI if it's essentially the same basic concept? Because BMI has a more complicated formula. Let's pull up our guided worksheets and skip ahead a little bit, since this is relevant. Remember, your guided worksheets have previews for every single Excel, including the ones we don't do. So, where is it? Taxes, we don't do this one, but there's a preview. BMI, here's a preview. You're supposed to be putting this formula in, and it's going to be put into a table that looks kind of like this. So you'll have some numbers along a column, you'll have some numbers along a row, and then you'll type a formula in once at the very top part, the top left blank. But it's not just going to be this thing times that thing, it's going to be this formula right here that you'll have to turn into Excel. So you'll need parentheses, you'll need exponents, you've got multiplications, maybe you need an additional parentheses in the top, maybe you need one in the bottom, I'm not going to tell you. But I will tell you, as I've already told you a dozen times now, you will need to put fixed cells. So this weight may be going across the row or the column, so you'll need to fix either its row or column. The height, same thing, but opposite. So one of these will need the letter fixed, one of these will need the number fixed, but I'm not telling you which one. All right. So again, here's the same thing you had. It's like the 4th time we've seen it, how these work. Cache in front of the letter means the letter doesn't change, which means it doesn't move left or right. Cache in front of the number means the number doesn't change, which means it doesn't move up or down. If you do it in front of both, they don't move at all. That particular cell reference doesn't move at all. And you can have formulas where one cell moves and another cell doesn't, or one cell can move left and right and one can move up and down, just like we just demonstrated. Again, I cannot emphasize enough the importance of making a multiplication and or addition table and doing it again, and then 3 days later doing it again, to make sure that you've got a good starting point for the BMI homework. Because if you can't do fixed cells, you cannot even begin the BMI homework. All right. 1.3. Back in, well, we're still on 1.3. I don't know why I just said it again randomly. Occasionally, you'll be asked for domain and range in your My Math Lab homework. It's a pretty simple idea. And for graphs, that is. We've talked about domain and range in terms of just numbers. Domain is the list of inputs, range is the list of outputs. Well, on a graph, domain is how far left or right you can go, range is how far up or down you can go. So you might have a couple of homeworks dealing with that. Admittedly, I don't think I test on domain and range for this course. I don't think I will test. I haven't in the past. I probably won't start now. But you got a homework question or two, so just make sure that you understand that. But you have to view an example and help me solve this, so I'm not going to go into that. Remember, this is not a class where I get to teach during the lecture every single thing absolutely. There are things that you're going to see in the homework that you may not have seen in class, but they shouldn't be out of our pay grade, which means you should be able to figure them out based on view an example, help me solve this, or any extra resources. And then pay attention to where the units are. This is just a common issue throughout the rest of the semester. Pay attention to where your units are. Are they in the top? Are they in the bottom? Miles per hour, where, you know, what goes in the top, one goes in the bottom, and are they both in the top, both in the bottom? Miles will be top, hours will be bottom. Also, paying attention to where units are could be just in terms of answering things. So your horizontal axis might be dollars and the vertical axis might be number of units sold. So it could be like a supplier demand graph. The answer is not just a number, the answer would be dollars or units. So if they ask you about a number on the horizontal axis, you'd have to say dollars. If they ask you about a number on the vertical axis, you'd have to say units. So pay attention. Ask yourself, does it make sense? And pay attention. This right here, and I think this is the last bit in my little notes to share before we go on to the next guided worksheet. This is the payment formula for Excel for mortgage and car payment. This is something that you will see as a question or two coming up that we're going to kind of skip over. This is a little above our pay grade, that phrase I just used a minute ago. Admittedly, for chapter 1. This is something that's seen in chapter 9, and by chapter 9, you're ready for this. I'm not really a huge fan for now, but let me pull up where this is on the guided worksheets for y'all on page 44 so you can see what I'm referring to. Page 44, here we go. So the next guided practice activity is a monthly car payment as a function of 2 inputs. So this is the car payment formula. This is also the mortgage payment formula. Again, this is seen in chapter 9. You might just see it in passing once or twice until then, but I will never test on this for now. In the midterm, this is chapter 9 material. This is not really chapter 1 material in my opinion, but it is a very important concept that we can go ahead and at least talk about as long as we have Excel in front of us. So given an annual percentage rate on your loan, the number of times that you have to pay that loan, which is generally 12 for a car payment or a mortgage, but there are exceptions to every rule, and the amount of time and years that you'll have that loan along with the principal, so P for principal, APR, very often abbreviated as just the letter R, N for the number of periods in a year, generally 12 for months, and number of years is T. So you would have to put those 4 numbers into this formula and then hit enter on your calculator or hit enter on your computer if Excel is doing it for you. So this is the, quote, math version of the formula. Let me see if I can do this. This right here is the Excel version of the formula. So you wouldn't have the PMT part. You would just start with here, equals, blah, blah, blah. I'm just making sure that you can tell, yeah, that's the payment formula. So you can see this top, P times APR over N, because it's the top of a fraction with other stuff going on, you end up needing this extra parentheses. So that parentheses is not seen on the worksheet on the left. You would have to figure out that you need it. That is very similar to the earlier problems I said you'll have to do that I'll set up after class. Okay, then you have your big division bar, which is this slash right here. That's the big division right here. Then the 1 minus and another parentheses. So they actually have the outer parentheses here, but guess what? That formula does not have to have this outer parentheses written. You might have to figure that out as well. So here's the outer parentheses. This one right, come on, let me highlight the right thing. There. Then the 1 minus, then the extra parentheses, then the 1 plus. They have the APR over the N in an extra parentheses just to be safe. I will admit that that one is not necessary. This particular, that parentheses is unnecessary, but it doesn't hurt to have it. However, then you close the parentheses. So this one was necessary. That's closing this guy right here. Then you have your caret for your exponent, and because there's multiple parts in the exponent, you need a parentheses around that. So again, a little above our pay grade for now, but it is part of the course ultimately. All right, so let's get to the guided activity. You have just bought a new Volkswagen Jetta for $17,254.38. That is a no bells and whistles Jetta in 2020. I'm pretty sure those are usually closer to like 18, 19,000, but whatever, not the point of the problem. You choose to put down, so this is money up front that you pay to get the loan very often, $2,254.38. Now, do you have to put exactly that much down? No, maybe a little less, maybe a little more. It depends on the loan, depends on what you want to do. You can always put down more than the requirement, and maybe there's a reason to do that. Hold on a second. Okay. So we're only going to borrow $15,000. This right here is the principal on this loan. $15,000 is the principal. Principal means amount borrowed or amount loaned. Now the auto dealership is going to give you a loan from the bank for 5 years at 6%. If you've got good credit, 6% is a little high right now, but it is what it is. So you agree to sign, and they want to know what your fixed monthly payment is going to be. So you've got a principal of $15,000, an APR of 6%, a loan of 5 years, and you're going to make monthly payments. How do you know we're making monthly payments? Because it says monthly payments, because we read the problem again, we read the problem again until we get all the information absorbed. Critical reading skills are important. So the N here is 12. So this, the numbers I'm about to write and then erase are only true for this one particular example. You'll see that we're going to have a giant table of options. This is really what we're more interested in. But for just this particular problem, I got to put on annotate. The principal is the 15,000. The APR is the 6%, which is a decimal is 0.06. If you're using a traditional calculator, you'd need it that way. Number of periods in a year, that's the number of months in a year since we're paying monthly. Number of years on the loan, that's 5. So that's our P, R or APR, N and T that would then go into this formula and you'd be able to crunch that out. Now I will show this one time on the calculator. That's not gonna work. I gotta take it off of annotate, there we go. This is what it would look like. Parentheses, the principal of $15,000. Then times the APR, which is the 0.06, divided by the N, which is 12, and close it. So that's the top portion, then divided by, and then we open another parentheses. That's this big one right here, which again, does not have to be seen. In fact, the formula sheet I gave you, I don't have it there. So then 1 minus, parentheses, 1 plus. They put a parentheses around the APR over N. I said it's unnecessary, so I'm not going to write it. So that's the same 0.06 divided by 12. That's a times divided by 12. Then we'll close this parentheses before the exponent. Make our exponent with a caret. Because this negative NT has multiple pieces, that needs a parentheses. You, depending on your calculator, might have to hit the negative first or last. I have to hit it first. So negative, and the n and the n was 12 times the t was 5. Close the parentheses, make sure you have as many open as closed parentheses, double check that. Open, close, open, open, close, open, close, close. We're good. Drum roll. And we get $289.99. If you don't get that answer typing it out, that means you need to practice or figure out your calculator a little bit more. And again, this is end of the semester material. I'm not doing this right now. I'm not expecting this right now. There's 1 or 2 homework questions with it, but I wouldn't test you on this yet. Okay, so I need to scroll down, so I have to clear the screen. I wish I could clear without having to go back to annotate first, but whatever. So Excel, here's the Excel spreadsheet that they have for us. So what they have done is they had the 15,000 here, the 6% here, the N of 12 here, the 5 for the T here. Then in this highlighted cell right here, they went equals, they typed out this formula right here, but with cell references. So instead of P, they would use cell A2. Instead of APR, they would use cell B2. Instead of N, they would use cell C2. Instead of T, they would use cell D2. So they go equals, they do that formula with cell references, and look at that, they get 289.99, the exact same answer. Now you might have said, well, Mr. Beckner, why did you round to 2 decimal places? Because money. Money is always rounded to 2 decimal places unless specified otherwise. Sometimes we'll round to the nearest whole dollar, but again, the instructions would tell us to do so. So all we've focused on for now, all we've done is this up here. Not the big chunk of the table, just this little section. So question 1, what are the 2 specific inputs for APR and term for the highlighted payment of $456.33? So now this table, this is doing what we call what if analysis. I want to add this to our the notes over here. Now this won't be in the file. This is something you have to add. If you see me type things, it means it's not in the original file. So what if analysis. This is using tables to generate many, many, many scenarios. Tables generally using Excel. So what the rest of this table does for us, it says, okay, Bob or you or Jane or whatever, Bob and Jane are my 2 favorite people, they got a 6% loan for 5 years on 15,000. But what if they had a better credit score and they were able to get a 2% loan? Or what if they want to pay this off quicker so they get a 2-year loan? Or what if they need to take longer and they get a 6-year loan? Or what if their credit is terrible and they get a 10% loan? Or what if their credit's mediocre and they get a 5% loan? So this is going to go through a range of possibilities, 10 different APRs, 10 different credit ratings, basically, potentially, and 6 different terms of time, lengths of time in years. So what we would have done in Excel here, if this was a homework, which it is a homework that I don't assign, and you're welcome for that because of the complicated formula, so that's why I don't assign this one. But I could. I instead choose to use it as the guided worksheet. So in this cell right here, cell C7, you would type equals, and then the formula would be very similar to the one you typed up here in the yellow box. It would still have all of these components, and you'd still be referencing the $15,000 part, and you'd still be referencing the 12 part, but we want to do a bunch of different APRs, and we want to do a bunch of different times. So we would no longer reference cell B2 and we would no longer reference cell D2. We would instead reference these cells B7 through B16 and these cells C6 through H6. Now, guess what? This is a table with different rows and columns, kind of like a multiplication table, kind of like an addition table, which means some cells would need to be fixed and some would not. Maybe you're fixing the rows of some, maybe you're fixing the columns of some, maybe you're fixing all of them. So you'd have those complications here. So all we do is we type that formula here once with the correct dollar symbols in place. We would fill it down, we'd fill it right, and then all of this would be applied. So you can see, okay, the person who gets a one-year loan and is paying 1% is paying $1,256 a month. Holy cow, who can afford that as a car payment? Well, maybe someone making $50,000 a year living with their mom still. So maybe they just want to go hard and, buy a $80,000 BMW or something like that. Can you even get a BMW for $80,000 now new? I don't know. I'm a teacher. Clearly, I don't know. I'm in the Jetta. Well, I used to have a Jetta, actually. Now it's a Civic. But either way, cheap cars. Cheap and effective. I love my Civic. So, alternatively, what if you got that 1% loan but paid it off over 2 years, $630 every month? Now, what you might think is, well, if it was $1,250 to pay it off in 1 year, you should just be paying half as much if you're going to pay it off in 2 years, half as much every time. But if you took $1,256 and divided it by 2, 1256.78 specifically. If we half this, this is what you might think you're going to pay every month if you double the length of the loan, $628.39, but you actually pay a little more than that, $631.53. So by doubling the length of the loan, you pay pretty close to this number, but it's, about $3 higher. Why is that? Compounding interest. Remember when we had that TV loan problem earlier, where the first month we paid $10 in interest and the second month we paid $10.10 in interest because we're paying off the principal and the principal kept getting bigger and bigger? It's kind of the same idea here. Because we're taking longer to pay this off, the principal isn't dropping as quick, so you end up paying a little more in interest. So compounding interest helps you when you're putting money aside, and it builds and builds and builds. But it also hurts you when you want to take a loan for longer and longer and longer. You pay more interest on a longer loan. You pay more interest on a higher interest rate as well. So you can see that by having a 1-year loan going from 1% to 2%, you go from paying $1,256.78 a month to $1,263.58 a month. So that's another $7 roughly, just by having a 1% higher rate. And then if you go up another percent, it goes up about another $7. And it's not exactly the same each time, but it's about $7. So you might say, all right, well, in this table, where do I want to be? What can I afford? I can afford a $300 a month car payment. So that says, well, I certainly can't get the 1-year, 2-year, 3-year loans on any of these options. I can't get the 4-year loan option either. I could certainly get a 5-year loan, but I couldn't have 10%, 9%, or 8% interest. I'd need to have a 7% or lower. So these are affordable. Or if I took 6 years to pay it off, it wouldn't matter what my interest rate is. So if you can afford $300 a month for your car payment, that says you can take any of the 6-year loans, or you can take a 5-year loan as long as it's 7% or lower. Maybe you can afford $250 a month. Well, that means you have less options. You've got to take the 6-year 6% or lower interest rates. You can't even take a 5-year loan. Maybe you have more money. Maybe you can afford $500 a month. You can't take any of the 1 years. You can't take any of the 2 years. You could take all of the 3 years. You could take all of the 4 years, all the 5, all the 6. It wouldn't matter what your rates are. So there's some play with this. It depends on what you can afford. The point of this is really though, all right, so a car company says, we'll give you a 3-year 2% loan. You can use this to calculate your number and know whether or not it's going to be okay. All right, getting to the actual questions at hand. What are the two specific inputs, the APR and the term, for the highlighted payment of $456.33? So not the 289, I know that's highlighted, they're saying this one now. And this 289, you can see, is the same 5-year, 6%. That yellow one is the same as this one. But we're talking about the blue one, 456.33. So if you move up, you can see that it's a 3 here, which is the years. And if you move left, you can see that's a 6%, which is the APR. So the APR is the 6%, and then the term is the 3 years. So the APR would be the 6%, and the term was 3 years. for the highlighted payment of $456. So it's the same rate as the original, singular problem, but it's a shorter amount of time. And that's why the payment goes from $289.99 to $456.33. To pay it off quicker, you got to make more payments. But I can tell you, by paying it off quicker, you'd pay less in interest. The sooner you pay it off, the less interest you pay. The lower APR, the less interest you pay. What formula is entered in cell C7 that will allow us to fill down and across? Note, you may use the number 12 in your formula instead of the cell reference, since this is constant for monthly payments. In particular, pay attention to what cell references are absolute, relative, or mixed. So some will need double cash symbols, some will not, some will need single cash symbols. So I'm just going to go ahead and give this to you straight up because, again, this is not a question that I really want to be done at this point. I'll give it to you, and then we'll talk about why each thing is done as it is. Cash A2, and I can't see that, so I got to move something that you might not be able to see. Then times cash B7 slash, I'm actually going to use the cell reference though, instead of typing 12. So I'm going to use cell C2, but we don't want C2 moving at all. So that's why we're going to double cash that one. The A2, we also don't want moving at all. This 15,000, we don't want to move down or right. We always need to be here, which is why I double cash that cell reference. This is the A2. Then this is a times. The B7, that's right here. So this is the B7, which we only want to be using the purple numbers, which means we only want it moving up or down. We don't want it moving left or right. If we don't want it move left or right, we can't change the letter, which is why the letter was cashed. Then again, the divided by, this was the 12. We don't want this one moving down or right, so double cash. Close the parentheses. Then divided by. Then we open the parentheses, then a 1 minus, open another one, a 1 plus. And then this is supposed to be the cash B7 again. Again, this is using the payment formula from before that I can't go to at the moment. So 1 plus, then divided by, this is supposed to be the N, which was the C2, but double fixed. And then we close that, then we have our exponent, then we open a parentheses, then it's the negative and the N and the T. So that's the N, which is the C2 again. Cash C, cash 2. And then times, this is supposed to be the time. The time is these dark green numbers. So we want to use this as our reference, and we only want it moving left or right. We don't want it moving up or down. So if we don't want the row to change, we fix the number. So we're going to do that C6, so C cash 6. And then close 2 parentheses. So that's the formula. So again, I'm not super interested in that one. I actually skipped that in class. I show the answer, but I don't have students do it. 3, how much total interest is paid with the $289.99 monthly payment? So this is going back to those basics. Go off of annotate. Basic finance formulas. Right here. These that I said will never go away in this class ever, especially the top 5. So we want to find out how much interest we're going to pay. Well, to find the total interest, we need to know how much we paid in total and subtract the principal. We know the principal is $15,000, but we don't know how much we paid in total yet. So we'll definitely need this, but for now we're questioning what's the total paid? Well, the total paid is the number of payments times the payment. How do you find the total number of payments? That's the number of payments per year times the loan term. So we got to first find the total number of payments. Then we'll find the total we pay. Then we can find the total interest. So we are specifically looking at these three. The total number of payments is the number of payments per year times the loan term. Again, that is a concept, not a formula. You should know that. Total paid is the number of payments times a payment. Again, concept. What are you paying? How many times did you pay it? Multiply. Total interest. That's the difference of what you paid and what you borrowed. But we're not paying $289 total. That's just 1 month. There's a lot of months that we pay that. So we have to add all those up first. All right, so back to annotate. So we first need to find the number of payments. Then we can find the total paid. Then we can find the total interest. That's the 1, 2, 3 winning combination. All right, so the number of payments, well, it's 12 times a year, and then how many years? Well, we're paying, and this was the $289.99. We're back to that. We're not on the $456, we're on the $289.99. So we're paying that for 5 years, 12 months at a time. So that's 12 times 5, which is 60. So there's 60 payments. Well, each time we make a payment, we're paying $289.99. So the total paid is $289.99, and we're doing that 60 times. And I don't want to have to keep taking annotate off, so I'm just going to do it as a calculator. $289.99 times 60 off the screen, and that's $17,399.40. $17,399.40. So that's how much we pay the loan company, the bank, the car dealership, whoever we borrowed from. $17,399.40. To find out the interest, that is the difference of what we paid and what we borrowed. We paid $17,399. We're ignoring the down payment in this, by the way. And then we subtract off the $15K. I'm just going to write, now I can fit in the zeros. So that says that the interest, that's pretty easy to subtract, you should get $2,399.40. That's $2,399.40. $2,399.40. And that's it. This is a concept that we'll use in this course over and over and over. We'll do it a decent amount at the beginning. We'll do it a decent amount at the end. We don't do it too much in the middle, though, so this will come back. It's kind of weird how we start out talking about finance. We don't talk about it too much, and then we come back and talk about finance at the end. Unfortunately, I didn't design the course. I would have played things a little differently, but it is what it is. It's still, there's nothing wrong with this. The only thing that's sucky is the complex formula, but at least for now, you didn't actually have to do it. So question 4, and I'm unfortunately going to have to erase my screen. How much would you save in interest if you switched your 5-year 6% loan to a 3-year 6% loan? So we're going to compare the yellow highlighted bit in the table to the blue highlighted bit in the table, the 289 and the 456. So they want to know, how much would you save if you're, first of all, able to afford the higher payment? And by paying that higher payment, that will save you money in the long run. So if you pay $456.33 a month for 3 years instead of $289.99 a month for 5 years, how much do you save? I'm going to try and squish this in without actually erasing it, because I'd like to leave everything up there for now. So the first thing we need to do is we got to say, well, what's the 5-year 6% going to cost us in interest? We need to do everything we just did in problem 3, but with the 5-year 6% number, with the 456.33 number. So the number of payments, we're paying 12 times a month, but now instead of paying for 5 years, we're only paying for 3 years. So we only make 36 payments. Yeah, we're making a bigger payment of, from going from like 300 to 450, we're basically making a 50% bigger payment, but we're only going to pay it for 3 years instead of 5 years. Okay, so the total paid, we're paying $456.33 a month now, but we're only going to pay that 36 times. And if you do 456.33 times 36 months, you should end up with 16,427. I don't know why that looks wrong. Let me double check my math. 456.33 times 36. And that's right. 16,427.88. So $16,427.88. Now, if you analyze well, you should be able to tell at this point that this is a better deal, because last time we paid $17,400, now we're paying $16,400 roughly. So the question though it was not how much do you pay? It wasn't even how much interest do you pay on the 5-year 6 loan, it's how much do you save? But we still need the interest. So the interest is the difference of what we just got, that's $16,427.88 minus what we borrowed, which was the $15,000, which should be $1,427.88. $1,427.88. Now, I'm not boxing that up because that's not the answer. Again, they did not ask what's the interest, the total interest on a 5-year 6% loan. They said, what's the savings? So what we're going to do is, I'm going to write it up here, compare interests. We are interested in the different interests. Sorry for the terrible pun. I'm horrible. By compare, I mean subtract. What's the difference of them? So we've got to take the higher interest of 2, 3, 9, 9, 40, and we're going to subtract the 14, 27, 88. So if we take 2399.40 and subtract 1427.88, you get 971.52. That was ugly. 971.52. This right here is our savings. This is the answer to number 4. So a person who is able to afford the 3-year loan versus the 5-year loan at the same rate ends up saving almost $1,000 that they don't have to pay to the bank or the car loan company or whatever. That's awesome. Now, are you able to handle the extra $150 every month roughly? I can't tell you. If you can't, then you're stuck paying the extra interest. And it is what it is. But if you can live a cheaper life, maybe you can just not spend $150 at Starbucks. You can get your car paid off quicker. Then you'll have 2 years where you're not even making a payment, and you will have an extra $1,000 in your pocket. And then you can get back on your Starbucks habit. Or maybe you take that extra money and you invest it, which would be my suggestion, but I won't tell you what to do. How do we invest? We'll get into that by the end of the semester. So a savings account is not an investment. Mutual fund is not an investment. I'm sorry, I just said that wrong. A mutual fund is an investment. I said not when I shouldn't have said not. So we have done 1 through 4 together. I need to clear my screen, unfortunately. Remember, you can always go back to YouTube and pause if you don't get to writing something down. Question 5. What if you have a horrible credit score? You might be forced to take out a 6-year 10% loan. How much interest do you pay over the life of this loan? So number 5 and number 6 are going to be discussion boards. What is fixed, column or row, by the following cell references? So for 6, your answers are going to be both, neither, row, or column. Let's see, for number 5, we can say that one person can take out, so person 1 can calculate the total paid. Then once person 1 has posted that, person 2 can calculate the interest. Now, person 1 technically has 2 things because they have to find the number of payments, which is just 6 times something. Then they take that number and do something else to get the total paid. If you get an answer that's less than 15,000, that wouldn't make sense on a total paid because you borrowed 15,000. You're not going to pay less than what you paid. If you get an answer that's like $30,000, that sounds pretty bad too. If you get anything more than $10,000 for interest, that's definitely wrong. This will be a large amount of interest. It will be the largest out of what we've seen. It's the largest for the entire table. But it should be in a ballpark of reasonability. For question 6, I don't want 6 different people answering those. So let's have someone do the first 3. So person 1, and then someone do the second 3. So that's person 2. So 4 people can get credit for this one. Out of the previous work from before, I don't remember how many I had circled, but there's a lot of opportunities, 1 per question. So there's probably like, I don't know, 12 to 15 opportunities to get an answer, to get a discussion board point is what I call them, because you do have to participate here and there. Like I said, you don't have to participate in every single thing. Do not answer every single question. Please give other people opportunities. But I have to see some participation throughout the course. How are we on time? Okay. Clear screen. Go off of annotate. I cleared my screen. Why didn't it clear? Maybe I hit undo. Maybe that's what happened. All right. So another quick guided activity, and I'm just going to be giving the answers for these because it's charts and stuff. To make an effective chart, blah, 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 blah. Let's assume you want to make a chart based on all this stuff. So this would be an Excel homework, but again, I'm not going to do that. So you'd want to make a chart with all the different possible payment options, but just for a 5-year loan. So we're only worried about the 5-year loan. We're only worried about the 5-year loan. We want to make a chart out of all the options for a 5-year loan, which is this column right here. So they say, what cell range should you highlight for this chart? Well, you'd want to highlight these, which goes from G7 all the way down to G16. So I'm not going to type this. The answer to number 1 is G7 colon G16, G7 colon G16, G7 colon G16. That's the answer number 1, and that would be these right here. The following chart does not have the correct x-axis label. How do you get the APRs to show up on the x-axis? So here's the chart title, the chart that they want you to make. But unfortunately, when you do it that way, the numbers, because you didn't do all this, you didn't highlight these as well using control to separate the different sections. It just says 1 through 10 instead of like 1%, 2%, 3%. Now, it's a coincidence that these are the appropriate numbers without the symbol, but that's just a coincidence. So I will type this up. Click on Select Data, and then Edit Horizontal Category, Axis Labels by selecting cells spelled the correct way, B7 through B16. So B7 through B16 were the labels. So that's what you would have to do. I had mentioned in class during the second day when we were practicing all the Excel stuff, building that first Excel file, that it is much better to go ahead and have them highlighted up front. But if you forget to, if you ever get a chart that looks like this, which would be marked wrong, you can go back and edit it, and this is how you edit it. How do you add an axis title? Well, you just add chart element. Go to add chart element, which when you have that chart active, that should be in the upper left section of Excel. How do you make the columns wider? You can do one thing, which I showed you in classes. You can take your mouse and you can put it between the two letters, and I can't do anything really. I can't actually, this is just perfect, isn't it? Up here where the letters are, here's letter D, here's letter E. If I wanted to make it wider, I could click the line between them, and then I can move it left or right while I'm holding, and that could make it wider. Alternatively, shoot, annotate, take that down, annotate, there we go. Alternatively, you can right click on a column and choose Format Data Series and set gap width to something else. A width of 5% or 6%, you can do things like that. There's options. It's not my suggested way to do things. I would prefer just to go up to the top and click and drag. It's a lot easier. And that, my friends, will close out chapter 1. So we've got a decent amount of discussion boards questions available for us. I'll post that. I'm actually going to be able to end class a few minutes early, so I will definitely have this set up by 11 o'clock. So the discussion board will be set up, your quiz will be set up. Let's go back to everything that we need. Let's clear our screen, take off annotate. So again, discussion boards. For the first class, I said I'm going to give you an extension of a day. And then today's will be due on 6/2. So there will be a separate discussion board with all the stuff I detailed today. That one's going to be due on the 2nd. You also have quiz 2 that is due on the 2nd as well. Remember, quizzes and discussion boards are due the next class. My math lab and Excel homeworks are generally due in a week. I want to go ahead and point out, in case you want to get ahead, the next 2 Excel homeworks are 1.3, the car loan, and 1.8, the BMI. I don't want to have too many due at once, so since Excel heart rate's due on June 2nd, the car loan will be due on June 9th, then the BMI will be due on June 16th. So that's 6/9 and 6/16, respectively. Okay, so if you have any questions, please feel free to email me. If you haven't purchased your My Math Lab Access Kit yet, you're going to need to do that pretty soon because your 2-week free trial is about to run up. Anyone who's not in My Math Lab is going to be removed from the course, as we said. and keep up with the work, keep working hard. Remember, put in like 8-9 hours a week on this course. If you're not putting 8 or 9 hours in and you don't understand something, that means you need to study more. Go back and watch the videos again, take better notes, read your notes, work more on the homeworks, do the homework problems again, do the Excel homeworks again. Remember, you get 5 attempts on Excel homeworks. So that's a pretty reasonable amount of numbers. I've heard other teachers only give 2 or 3. The first time we did this, we were only doing 1. Well, we were supposed to. I was doing 2, but we were told to do 1. So have a good one. Have a good weekend. Stay safe, stay sane, stay working hard. We'll see you on Tuesday.